So I understand that graphing is not always the best way to do problems with systems of linear equations. That's because graphing can be not very accurate. It also can be kind of tedious to actually graph the question. So here's an algebraic method to do the same thing and to come up with an answer. When solving a solution graphically, most solutions are approximation. So again, that means that we're guessing what our answers are going to be based on a graph. So in this section, we're going to learn how to solve a system of linear equations using the substitution method. How this works is by using substitution, we transform two linear equations into a single equation in one variable. So that basically means we're going to sub in something so that we only have one variable in one equation instead of two variables in two equations. We then use what we know to determine the value of that variable. Alright, so the first thing we have to do with step 1 is we're going to have to get one variable by itself. So I saw that in equation 2, this y was the easiest variable to get by itself because it only had a 1 in front of it. So since it only had a 1 in front of it, I could easily move the 4x to the other side, and then that y is all by itself. Step 2 is then we're going to substitute that into the other equation. So what I'm saying by that is that I know that this is what y equals, so I'm going to trade the y in the other equation with what I just found y equals. So again, y equals 5 minus 4x. So 5 minus 4x is going to go in for y. So I'm trading what was y in equation 1 with 5 minus 4x. From there, we're just going to do the math to find x. So now, to finish this question, we have to figure out what x equals. So this is just about solving to get x by itself. I'm going to start by multiplying that minus 4 into the brackets, because brackets mean multiply. So when I multiply that minus 4 in, we get a 2x minus 20, because minus 4 times 5 is minus 20. And then minus 4 times minus 4x is positive 16x equals 7. So again, I'm just multiplying the minus 4 into the brackets. This is linear, so we just combine like terms. So I see here that I have a 2x and a 16x. So when I put them together, I get 18x minus 20 equals 7. Now we're almost done. I can add the 20 over because I want it to be with the 7, so that again I've combined all like terms. So we're going to get 18x equals 27. And then final step, divide out that 18. So I get an answer that x is 1.5. That's the x value where your two lines cross. So this is the x of the solution. Your two lines are crossing and x is 1.5. Okay, so part 3 says solve for the other variable. So my equation was 5 minus 4x. And if I take 1.5 and I put it in for x, we get 5 minus 4 times 1.5, which is 5 subtract 6. So that means that y equals negative 1. So the y value, where my two lines cross, is going to be at negative 1. Well, the x value is at 1.5. We can write the solution as a coordinate, just like with a graph. 1.5 and minus 1. Again, that's where your two lines will cross, and we figured it out algebraically. So we can finish then by checking. So we're going to check in equation 1. So we have 2x, and x is 1.5, minus 4y, and y is negative 1, and that should equal 7. So 2 times 1.5 is 3, minus 4 times minus 1 is plus 4, equals 7. And you can see that, yes, 3 plus 4 does equal 7, so my answer does check. So that is my answer to the question. So let's try another example of this. This one says that on dance recital there was 220 people. The ticket costs were $8 for an adult and $6 for a child. In total, they collected $1,614 in ticket sales. How many adults and how many children attended the recital? So let's start by setting up our variables. So if we let x equals adults and y equals children, then x plus y will equal 220 people. And then the other equation is going to deal with money. So it's $8 for an adult and $6 for a child. And when you add up the ticket sales, they got $1,614. So here and then to start, we would have our two equations that make up our system. So step one, we need to get a variable by itself. This time I'm going to get this x by itself. That just seems like the easiest one to do. So that means if I subtract the y to the other side, we'd get 220 subtract y. So again, first of all, I'm getting the x by itself just by subtracting that y to the other side of the equation. So x equals 220 minus y. So we're going to trade now 220 minus y in for x in our second equation. So step two is we're going to take 8, and then instead of writing x, we're going to write 220 minus y, because that's the same as x. Plus 6y equals 1,614. So again, this was x, so I put it in for x in the other equation. From here, we're just going to go through and solve to get the y by itself. So when I multiply that 8 in, then we get 1760. Yeah. Minus 8y plus 6y equals 1614. Okay. Now we combine like terms. So I see that I have a minus 8y and a plus 6y. So that means I have 1760 minus 2y when I combine them. Now that's 1760. Let's move that over. How do I move the 1760? Subtract it, right, because it's a positive right now. So I'll subtract the 1760 over. So we get minus 2y equals, and then we'll divide out that minus 2. So we're going to get y equals 73. Y equals 73. What does that mean? If y is 73? That's the amount of children that attended. Yes. So my answer there is that 73 children attended. Now we can go back and find the adults. So step 3 is I'm going to use my answer for 73 children back into the equation that I came up with in step 1. So we say x equals 220 subtract 73, because there were 220 people total. If I subtract the 73 kids off, how many adults attended? 147. 147. Good. So that means 147 adults attended. Again, we should always write this as a coordinate. So I would write my x first, and then my y value. So 147 and 73. So again, to check, you're just going to plug in your x and your y that you got in your original question, and make sure that both sides equal. From there, we're going to move on to these textbook questions, page 425, 4, 5, 11, and 12 for today.